Hi there, folks. So, I just really quickly wanted to walk through a 5-minute video just explaining the 5 different types of chemical reactions. So, there are 5 types of reactions that exist. There is double replacement, single replacement, combustion is one of them, combustion, synthesis, and decomposition. And so the way that these 5 reactions work is that they're actually kind of similar to one another. These two top ones, double and single replacement, as with the name, they're similar to each other. And then synthesis and decomposition, those two are also similar to each other in the fact that these guys are opposites of one another. Double and single replacement are related in the way that the reactions work. So with double replacement, the way that it works is it only works with ionic compounds. And the same could be said for single replacement as well. And so basically, what happens with double replacement is in a double replacement reaction, we're going to have a reaction taking place between 2 different ionic compounds. And I'm just going to pre write out parts of the reaction here so that they're a little bit easier for myself to manage. And what's going to happen is that you're going to have 2 different ionic compounds that react together. In other words, you're going to have the combination of some metal or some cation and some nonmetal. And what's going to happen is these the metals here, those two are going to actually switch places with one another. So all that's happening in double replacement is that guy there is switching places with the blue one there. And so when we get to the other side of the reaction, all that we end up with is the combination of now a new or the same metal, but with the other nonmetal, the same metal with the other nonmetal. So that's double replacement. Single replacement is very, very similar. But single replacement is very similar, except for one unique exception. And then I need metal plus just form metal plus. So with ionic compounds, I mean, you could think about double replacement as well here with switching the 2 nonmetals. You could think about it that way. Commonly, it's referred to as thinking of the 2 metal switching. With single replacement, the really key way of identifying a single replacement reaction is that you have some sort of compound reacting with some lone element. So some compound reacting with some lone element. And same as what happened in the last reaction, these two are simply just going to switch places with one another. The 2 metals are going to switch places with one another. Now, the reason I said there's a little bit of an exception is that when we start talking about single replacement reactions, it's not just the metal that switches places. It may also be that we have a lone nonmetal. So something like oxygen gas, for example, might be added in to this compound and it might cause the rusting or the oxidation. And in that case, the metal isn't switching places. It is actually the nonmetal that is switching places. And so that's generally what single replacement looks like. Combustion is kind of the unique one. Combustion always has the same components. It has a hydrocarbon, and similar to a fire, which is probably the most familiar combustion reaction to everyone, it's a hydrocarbon plus oxygen goes to form carbon dioxide and water. And what a hydrocarbon is it's exactly what the name says. It's some number of carbons and some number of hydrogens. And those can be any number of carbons and any number of hydrogens. Generally speaking, and most of the time, you will see there being more hydrogens than carbons. The tricky part about these questions becomes, well, what if you have some sort of reaction that's like C18H24? The tricky part then becomes, well, I need to balance this by putting an 18 in front of the CO2. So that's the tricky part about combustion reactions. But overall, the same basic elements and compounds are going to be part of it every single time. Hydrocarbon and oxygen react to form carbon dioxide and water. That's always a combustion reaction. Synthesis. The way synthesis works is it is a metal and a nonmetal that are separate and then they come together. Very simply, that's what a synthesis reaction is. A cation and an anion, or a metal and a nonmetal, separate, and they come together to form a metal and a nonmetal. And then decomposition is the opposite of that. That's where we have something that was previously formed, and that's going to decompose into its separate individual parts, like such, where it's going to break apart. And those are the 5 basic types of chemical reactions, generally how they look without being specific about the elements or compounds included. Hopefully that was interesting. Hopefully that was helpful. Let me know if you have any questions down in the comments section.